So, hi everyone. My name is Henri Binsztok, and I'm the co-founder at OKcontract. And today we're gonna talk about transacting agents. And this has been a hot topic, and it's how we let them transact freely, but under control. So this seems to be a contradiction, but we will go into that. This is basically how we automate these crypto transactions at the AI agent level, but without compromising security. So first, just a few words about the rise of AI agents. And it's already a very, let's say, big splash. It's a big market pumping in. There's Groundview Research and other analytics firm who predict 50 billion. And they may be even underestimating the total market 5 years from now, because AI agents can solve a lot of problems. They can replace humans doing work. But the problem is that there are AI hallucinations, there are errors, there are attacks, and they're not going away this year, and they're not going away next year, and they're going to stay for some time. So especially when we think about AI agents that do transactions, and for instance, financial transactions. And if we speak about this financial transaction, not necessarily blockchain, in fact, it's a very big market already. But the main risk is, what do we do with these errors, with these hallucinations, and how can we prevent basically the loss of funds in these transactions? And it's not something that is really easy. So let's talk about these hallucinations errors. So basically the first thing is AI models are probabilistic. So even if you reduce what is called the temperature, which is, let's say, the genericity of the model, you still have the probability that the model goes wrong just because of a single word in the input, and you just change a word and it becomes a completely different answer. And this is the way these models work. Maybe this is the way some humans work as well, but we have some error recovery mechanism which may be lacking right now in these AI models. And so applicable to transactions, and especially on-chain transactions, it means that the address of the contract that you're calling can be wrong. It means that the parameters can be wrong. And this is very dangerous, because even if you, let's say, whitelist the contracts that you want to interact with your AI agent, like say you do this at the ERC 437 session key control, you restrict, you say only interact with these contract addresses, they are very safe, I check them, etc., etc. It's completely insufficient, because there's a lot of DeFi contracts, for instance, where you can set a parameter to send the LP position to another address. And if you do that, basically your money is gone. And each step basically is a risk of error. And now we estimate that at each step, there's a 20% chance that the model will do something wrong, not what you expect in terms of security or just in terms of safety. So basically, if you do compound that on a 5-step chat, which is nothing, you have a 30% success rate only. And this is extremely, extremely low. So basically, it means that most of these AI agent sessions, they will fail. And it's just a probability. So it's funny that, for instance, even one agent in the Virtuals ecosystem, which is one of the most well-known there, it's called Luna, they even had to tweet that they themselves are frustrated, basically, with the recent transactions that they sent. It was tipping the agent, and there was a lot of reverts, so basically wasting gas, sending transactions for nothing, etc., etc. It's not even a loss, but it's still a problem. There's worse. A second thing are attacks on AI agents. And this is just only the beginning, because right now it's very easy to do prompt injections or other kind of attacks on these AI agents to basically trick them into something. And this is, for instance, AIXBT. You heard of this probably 2 months ago, got a rate of 55 ETH, basically by calling one tool which was already hard-coded. It was only tipping. So the AI agents was able to tip someone, but someone managed to inject a prompt and send the whole balance to their own address as a tip. So it's even if you whitelist everything, it's not sufficient. And this is prompt injection, could be social engineering as well. It's very easy, or to take, let's say, a developer access to some kind of admin function to that agent. So there will be a lot of sophisticated scams and attacks in the years to come, and there's no end to that. Which leads basically to a user trust gap, which we have seen, for instance, in several studies. Right now, if we talk about financial transactions, even beyond blockchain, only 20% of the people who are in charge believe that they can trust an AI agent to do financial transactions. And if we talk to something quite related, for instance, that was in the UK for loans, 73% of people want a human to decide, and definitely not an AI agent. And these features will be on-chain. We've seen what Robinhood announced, that they are moving most of their infrastructure on-chain in the coming years. So basically, this will be on-chain. So we need guardrails. Most naive approaches fall short. So basically, what can we do as a naive approach? So the worst thing you can do, obviously, is to tell the AI agent to write some code, some Python script or whatever, and somehow execute it later. Even if you try to add some guardrails, like generating tests as well, even if the tests pass, there's still a lot of ways that it can go wrong. So it's a very naive approach. There will be many ways to go beyond it. Another way that many projects are looking into is building manually a catalog of on-chain interactions. And for instance, they use JavaScript, and because they use JavaScript, they use most often the SDK of each project, and then this grows as a very big repo with thousands of dependencies, because for instance, if you use the Aave SDK and the Uniswap SDK, they both maybe use the same library, but not the same version in their package JSON, etc., etc. So you end up with a mess. If you want to support 1,000 or 10,000 protocols, this will be completely unmanageable, and it will be impossible to secure this and to audit this and to provide security for this. If we switch to another topic, which is not exactly in the same axis, but it's giving, for instance, what AIXBT does, giving the key to do transaction directly to the agent. So they say the agent is running on some server that I control, it's under my control. So basically, I just give it the key. It could be compromised. And then many people say, oh, we can use keys as well, but it's still a black box. The keys, there have been vulnerabilities on the keys themselves. And also, if you try to inject and to manage to inject something at the key input, depending on what software runs inside the key, then you can still attack it. What we propose is a solution where completely separate what we call the brain, like the decision, which we give to the AI agents themselves, and the brawn. The brawn is something which is not probabilistic at all. It's purely deterministic, and this is the way we execute these transactions in a fully deterministic way. And this is what I'm going to describe now, and which is basically a way to formally specify the interactions that you do with the blockchain, using a new programming language that is purpose-built for that, especially for statistical analysis and verification. So how our stack works, basically there's 3 components. The first component is we have this language that enables to specify interactions and verify them, and we are building a catalog of everything that is legitimate. And you can build, if you want to, custom versions of this catalog. Then we have a purely deterministic interaction builder which check properties of this interaction, and that will build it to build the code data. And then we have, for instance, if you want to build AI agent, which is this talk about, but it's one example of what we can do, is basically a specific agentic infrastructures like MCP tools, for instance, that you can embed to create your own AI agent using this stack. So let's talk about the catalog a bit more. So this catalog basically is not written in JavaScript. It's written in our own scripting language, which we call Lambda script. And Lambda script is a purely functional programming language, and we made this decision to, for instance, not use Solidity, but use another purpose-built language so we can do formal verification on it. And for instance, we have already generated coq proofs, which is a formal proof assistant, to verify that the specifications are correct for some properties. Right now, we don't have all of them, but we already have some of them. And this eliminates a lot of errors, not only the contract addresses, but also checking that all the computation, all the parameters for this contract are built properly. And for instance, that includes checking the slippage, and there's been as well some AI agents who were building transaction natively, and basically because of that, the slippage was was even missing. So basically, they got merged for almost all of it. Let's see how a specification looks like. So now we are building a developer portal where you can see the specification. So this is, for instance, for adding liquidity on Uniswap. You see, you have just a few descriptions here, which are the formulas, basically the expression in Lambda script of basically the interaction that we want to build. So from these transactions, and we basically have a secure transaction builders, which takes the input as a high-level input and basically compiles the whole interaction, checks all the properties on these parameters until we finally build the transactions. And the final construction that we have, we can check that it's correct versus the specification of the interaction, which leads us to now how we use it as an agentic flow. So basically, now we are building an agent. What we do is we somehow collect the intent at the AI agent level of what the users want to do. Then we query basically the OKcontract catalog to see what kind of specification do we already have that is consistent with the type of intent that the users want to do. And here I can add one thing, is that this is somehow an open intent architecture, because you may heard there's the intent architecture, of course, which is solved, let's say, behind closed doors by solvers, but you often don't have full visibility of the process of the intent resolution. Here, for instance, everything can be built client-side in the user browser or in a node you control, and you see exactly what specification you choose and how it is built, which is the first step, like we build it, and when it's built, then it's ready, it's safe, and we can execute it on-chain. One thing which matters for these AI agents as well is there's two things when you build an AI agent. There's the list of messages, the discussion, which is visible to every step of the model. Like every time you call the model in an AI agent, you send the whole history of messages that has been in this discussion. What you don't share, though, is what you can build inside the agent itself. It is the memory. And that memory can contain secrets, can contain things that the LLM models will not see. But you have tools, and the tools can pick whatever they need in that memory so that they can add it to the discussion so that the model can make, let's say, the best probabilistic decision of the outcome. And I mentioned that because, for instance, the selection of the transaction, the parameters, they are in memory. And in the memory, you can do all the deterministic work as opposed to probabilistic work in the agent model. Let's see a demo on how transacting looks like. So we're not, it's not a full chat product. It's just a demo. But you see, basically, you're typing, okay, I want to mint something on optimism. So here, it's pretty slow. I have some time to talk, and I can tell you why. Because this demo runs fully inside the browser. There is the agent itself is inside the browser. The LLM, the model itself, is running on web GPU inside the browser. So basically, this is a fully local transacting agent, which add, let's say, a layer of trust. Like at least you can trust that it may do very bad decisions because of the probabilistic outcome, but at least it's under your control. So you see here, it says, okay, this is what I found in the catalog. So for instance, I can mint several things. So basically we say, okay, let's mint the OK logo. And then it says, okay, yeah, I clicked on the link to see, we can see when it has chosen it. You can see the interaction on the OKcontract network, so you can see the actual contract, the actual parameters, etc. So we get back to the chat, where basically it says, okay, we're going to mint this. Are you okay? Are you willing to proceed? So this fully depends on the demo, where basically you can tell how much confirmation you want from your user. And then you see, in the memory here, we have selected the contract and we have selected the interaction. And now this is deterministic, and this is what we are going to build in a deterministic way. And you can see, for instance, here the memory. So now it says, okay, we are going to call that chain. It will cost that much gas, which is now 0 rounded, because it's even, there's right now an optimism, there's 5 zeros in the gas cost. It says, okay, do you really want to do this? We say yes. Note that there are no wallet interactions whatsoever, because it's just doing this on the AI agent session key. And then it's telling, oh, but and you can see now the transaction is minted. But you can think, but I told you before that we shouldn't let the agent have the session key. Okay? So, one more thing, and I'll end up here. I'm on time. We are doing something else. We are securing the execution of the interaction in the smart accounts. What do we do is there is one user master key which is kept off-chain, could be a ledger, could be anything. You have an agent session key, but we also are building a network which will be a decentralized network that verifies the transactions. And we have two fully implementation of this. The OKcontract SDK, which you find on NPM, is written in TypeScript and is evaluating the Lambda script, etc., building the call data in TypeScript. We have done a completely independent implementation of this. It's not even a ChatGPT translate this TypeScript to Go, not at all. It's manually re-implemented with the best practices in each language, and for the Go node. And the OKcontract network is completely verifying that the transaction comes from the specification in a fully independent way on a completely another code base. So this is how, basically, we can build trust on AI agents doing transaction, and even beyond that, doing any transaction using open standards. There's no T, there's nothing to hide inside a T. We have a path to decentralize everything. And this is why, for instance, probably Vitalik mentioned us, as you may know, in his talk yesterday. We were in the slide. He said basically use IPFS and OKcontract. And the third thing is goes along the same way of decentralization. We will make sure that everything we do could be censorship resistant, and it goes, of course, with full decentralization. And this is our roadmap. We're not fully live yet. We're in pre-beta, but it's coming along the way, and we hopefully have thought about how we can secure really how we verify and execute this transaction. So thanks a lot. I think we have maybe 2 minutes for questions. And but please follow the links and follow us on Twitter. You know, it matters for marketing. Do we have any questions?
You seem very negative on T's, which is an opinion I haven't heard much before. Is there particular reasons why, or any particular exploits?
So there were exploits previously with, for instance, Intel T's, and there may be others. The other thing is with T's is it's often a black box. You as a user, you don't know what's running inside the T. Most often you can't even be sure that it's a T when we tell you, oh, send your data to this T and never worry about it. And there's a third thing is even if it's a T, if there is any vulnerability with the software that runs inside it, and if you manage or you manage to hack and push some, let's say, untested inputs to it, maybe you'll have one outcome that you basically wasn't planned.
Okay, that makes sense.
Do you have any other question? Last one? Oh, no, we're out of time. You can talk to me afterwards. Thanks a lot to all of you. Thank you.